So now let's take a look at question 3. So yes, we're basically rapid firing these. Now eventually we get to ones where I actually have to do some solving by using my pen. Anyways, question 3. What is a geometric series? And then under what circumstances is it convergent? And what is its sum? And then part B, what is a p-series? And then under what circumstances is it convergent? Alright, so now let's take a look at the solution to question 3. So part A, so what is a geometric series? So recall from my earlier video, again, it's the same link as above there. So the geometric series is going to be displayed as like this. So and from summation from n equals 1 to infinity of AR to the power of n minus 1. And this equals to a plus AR squared, and then plus AR cubed, etc. And yeah, so that is a geometric series. And then under what circumstances is it convergent? So it is convergent if this R, this ratio there that you're multiplying every single time, or you're increasing the ratio there, is less than 1. And then it says what is its sum? And its sum is given by right here. So the summation from n equals 1 to infinity of AR to the power of n minus 1 is equal to a minus 1 minus r. I mean a divided by, not minus, a divided by 1 minus r. And this is for r, absolute value of r is less than 1. Yeah, so basically notice here's the first term a, and then you have the ratio there, common ratio. So if the absolute value of r is greater than or equal to 1, the geometric series is divergent. And here's more info. So in words, the sum of a convergent geometric series is the first term a divided by 1 minus the common ratio r here on all these terms there. Even this one, it could be r to the power of 0. And here's a geometric representation, again, hence the word geometric series. It's shown below via similar triangles where S is the sum of the series. So if you have something like this, let's make it bigger. So you have here, so here's a triangle, A, side A here, and then this entire sum is S. And if you go to a side here, so there's an A, and then if you draw a line all the way that's perfectly flat like this to make it a triangle, what you end up having is this side's going to be AR, like that. And then, yeah, such that you'll have, then this one here is going to be AR there. So this ratio is always the same. So if you have AA, the next one's going to be AR. And then this one here is AR squared, so you're always adding an R there, common ratio that basically has the exact same angle across here. Yeah, so it ends up being like this. So all these sides AR cubed, etc., and it goes all the way to 0 because it's convergent. So it goes all the way to 0, so you'll have it eventually go to the sum S, which is this whole side. Then you could use similar triangles and similar triangles as well. This angle here, yeah, this angle right here, is the same as this one right here. Just using our similar triangle setup, because remember, this goes like this and just straight down like that. All it is a Z. These are exactly the same, like that. Alright, so those are the same angle, so then what you could use is similar triangles, so then the ratios are going to be the same. So you can have A, the side, A over A minus R, so this one to this one is equal to this one, this inside one, S to A. Equals S over A, and you could divide by the A everywhere. And this is not AR, this is AR. You can divide by A, you get cancel all out, you get S is equal to 1 minus, A, yeah, A over all. Let's do it again, I got that mixed up. So again, you have it written right here. Yeah, so the ratio is A over A minus AR equals to S over A. Yeah, so S over A and A over A minus R. And now this part right here, this is, I'll just take out the bottom there. So A, 1 minus R. So yeah, so now these cancel. You could just multiply it over there and cancel out the same eyes there. Or you could just have it like this. This and this cancel, so that's 1, and then move this over, that becomes A. So you get S equals to A, 1 minus R. And that's this part right here. So anyways, I just wanted to illustrate that. And you can see my earlier video to go dive further into this geometric illustration. So anyways, that's part A. Let's look at part B now. Part B, what is a p-series, and then under what circumstances is it convergent? All right, so let's take a look at the solution there. So part B, so recall from the same video referenced above, the P series is this right here. So summation from n equals 1 to infinity of 1 divided by n to the power of p. And this is convergent if p is greater than 1, and it's divergent if p is less than or equal to 1. So basically, if this is large like that, for example, 1 over n3, greater than 1, then that's convergent. If it's less, so like, for example, if it's 1 over n, just the power of 1, that is divergent. That's very, very interesting.